Question number 8. Barium hydroxide combines with ammonium nitrate to become barium nitrate, ammonia, and water. So this is actually a reaction that Dr. Lottie has done many times in class. So this is an example of a spontaneous reaction that is endothermic. Which is something that we don't often think about. Usually when we think of spontaneous reactions, we think of exothermic reactions where a lot of heat is being released. However, here is an example where it's actually endothermic, so it becomes spontaneously cold. So this is a good example to see where entropy now plays a really big role in spontaneity. So if we look at this equation, delta G equals delta H minus T delta S. Because we know it turns cold, we know that delta H is greater than 0. Okay, so if it's greater than 0, but we know that delta G is less than 0, then we know that the delta S, because T can never be negative, right? So delta S needs to be sufficiently large to be able to overcome the delta H. So this is an example where entropy, the favorable entropy, is able to overcome the unfavorable enthalpy. Okay, so it turns cold, but the gain in entropy is much greater. So therefore, the reaction is still spontaneous. So for this question, we're not going to be doing any calculations because these involve ionic bonds. But the only any calculations about enthalpy, bond energy, or entropy. But what we're going to do is we'll calculate the change in the delta N. So the delta N for gas is going to be, so here we have no moles of gas. Here we have 2 moles of gas. So it's going to be plus 2. So remember in the previous examples we've calculated, we show that plus 2 will give us a work of about negative 5 kilojoules. So negative work is work done by the system. Okay, and then we can look at the N of the system, delta N of the system. This is going to be, so we have 1 mole, 2 moles, 3 moles. Here we have 10, 3, 13. So 13 minus 3 is equal to 10.